Welcome to part 5 of our Intro to Tidyverse series. I'll share my screen and we can get started. Okay, so you should be able to see it. Okay, perfect. Great. So the plan for today, and you should have the materials, right? We sent an email. Maybe Kyla can put the link in the chat again if you've missed it, so you can follow along here. So today we'll look at some more advanced wrangling commands, really useful, really powerful commands. Specifically, we'll do across, row-wise, and then we'll pivot, so reshape our data. And then we'll also talk about joining several data sets together. And just before we start, these are all really powerful functions, and we'll show you kind of the basic usage, what they do and how you can use them. But there's always more. They can do a lot more. So in every section, you can also find a link to the documentation or to what's called a vignette. So that's kind of a tutorial that explains how you can use the command and shows you lots of different examples. So if you want to learn more about these, then make sure that you follow those links and have a look at that. Okay, so first step, as always, is to load in our Tidyverse. Oops. And also today we'll use a bunch of data sets, quite a lot of them, all I think Tidy Tuesday, and I'll say something about them when it's relevant, when we start using them. And the reason why we're using so many is that we need the data to be in a really specific format to show what the different commands can do. So we need quite a lot of data, but hopefully the data is pretty easy to understand. Okay. Right, so I've loaded 4 data sets. You can see them up here as always. And we'll start with across. So across is a helper for mutate and summarize. So mutate, just as a reminder, mutate is when you can, or is the command you need to create a new column or to change a column. And what across can do really simply is, instead of having to change every column separately, you can change several columns at the same time, right? And summarize, that lets you do that lets you make these summary tables. So that lets you calculate the mean, standard deviation, sum, and so on of variables. And again, if you use that with across, you can calculate these things for several variables at the same time, not just for one variable. So that's really useful. And this falls under column-wise operations. So just the idea is just you can do something across, so for several different columns, for several different variables. And the way this works is that you can use these commands or arguments, starts with, ends with, contains, and so on, that you know from select. So select, that was when you picked out variables. So show me just these 2 variables, just these 2 columns, for example. We'll see examples in a second. So yeah, I'll jump to the examples. I think it's gonna it's gonna get clearer. So in this movie data set that we have, let's just take a quick look. Let's open it. So we've worked with that before a little bit, I think. So this is, again, this Bechdel test rating that we won't use that much today, but you can see we have film titles, we have the year that they were published, and then we have things like the budget, the domestic gross, the international gross, so how much it earned domestically, internationally, and then you have these columns as well: budget, domestic gross, international gross, but normalized to 2013, so kind of calculated as if they'd been made in 2013 to be able to better compare that. Right, so that's what it looks like. So let's say we want to look at every column where the column name contains gross. So we could use select, contains gross, and then I'm piping this into this structure call. So that gives us information on the data types. Okay, so now you can see I have these 4 columns. And you would think, okay, so how much a film earns, that should be a number. But it's actually treated as a character, so as text. So what that means, or that happens when there is some text, so some letters, some characters in the data, even though it should only be numbers. So as soon as there's a character in the data, R will treat it all as a character. And that's a problem if we try to calculate an average budget or something like that. It won't work if it's a character. So we could go through that and say, okay, mutate domestic gross equals as numeric domestic gross, and then do that for each of these. But we can also use across to do that in one step. So here I'm piping the movies data set, and I'm saying mutate because I want to change something about these variables. And then the next thing I type in is across, and then across wants to know, okay, across what? Across which variables? And here, this is where we can use this select, what we know from select. That's exactly how we did it in select, right? Contains gross. So mutate across every variable that contains gross in it, and then change it how is this argument, so as numeric. Right, so what that does, and I'll just execute that, is it says take all the variables that contain gross and make them numeric. So you don't have to do it for each variable separately. And now R will tell us NA is introduced by coercion. That's okay. So that means that everything that had some letters in it is now NA. Okay, so it's now a missing value. So that's fine for us for now. Okay, now we can check that everything worked okay. And I'm just repeating the same code from earlier. So where I'm selecting these columns and I'm piping that into structure, and you can see they're now numeric. So that worked well. Yeah, what we can also do with mutate and across is mutate across data types, basically. So you can see that we have a couple of character variables here. So the title, for example, the Bechdel test results, what else? The plot, and so on. Let's say we would like everything that at the moment is a character, we would like that to be a factor. So we can use across, and here we need to also use where. And the reason for that is that we're asking R to check for data types. So here we have to use across and then where. So every variable that is a character variable, mutate that so that it's actually a factor. So change that to a factor. And I'm not saving those changes because I don't want to overwrite that. I would just like to show it. Okay, so here we have the preview, and you can see that title, for example, is a factor now. That used to be a character. Test and clean test and binary and so on. These are all factors now. Okay, and of course you could do that with where is factor to character or something, or as character, right? You could do that with any data type that you like. Yeah, I'll just pause here for questions because across can be a bit tricky. So I'll just pause here before I move on. Are there any questions? Okay. Yeah, so that's across with mutate, so to change variables. But we can also use it with summarize. So let's say we would like to calculate the mean of all variables that contain gross. So now we need summarize instead of mutate because we would like a summary table instead of a change, right? But the rest looks pretty, or the next part looks really familiar. So we need across, and again we want variables that contain gross in the variable name. And what we would like to calculate is the mean. And then we also need an additional argument that NAs, so missing values, should be excluded. Otherwise, you can't really calculate a mean. So this just means ignore any missing values. Okay, so now you get a summary table for these 4 variables. And you can see these are the averages. Okay, and just another example to show a few more examples of this syntax. So here we had variables that contain a certain character string, so a certain sequence of letters. We can also use ends with and starts with. So here's an example with ends with. You could see that some of these variables have underscore 2013. So we can use across ends with 2013. And we would like, again, the mean. Okay, so now you see the mean of budget, domestic gross, international gross, all for 2013. And then starts with is exactly the same thing. So we would like the mean of all variables that start with budget. And here we have just budget and budget 2013. And what we can also do is we can say, calculate the mean for everything. So for all variables in the data. So we can just write across and then everything. That will, R won't like that. It'll complain a lot. You can see a lot of red here because it doesn't really make sense to, or you can't really calculate a mean for text or factors, right? But it will give you the mean of everything that it treats or it thinks is a numeric variable. So if you have a data set where most or everything is a numeric variable, you could use everything. Okay.
Yeah, we have a couple questions that maybe he can address. So the first one is, if it was a date like months 1 to 12, how would you deal with that?
So if you read in data and you knew that something was a date, but it's not treated as a date?
I'm not sure if the question is asking how you would identify it in a cross command, like how you would select it, or if it's asking what data type would be best for that variable.
Yeah, I mean, for dates, there is a specific date type, and there's a package called lubridate, or there are several packages, but lubridate is the one I know a little bit about. I'm not super familiar. I don't really work with dates a lot, but you can use lubridate. I haven't tried if that works in across, but I would guess that it does. There is lubridate has several as date or as year, or it has several functions. I haven't tried that, but I would guess that it might work just the same.
Yeah, and Janelle's also suggesting a package called clock, which I'm not familiar with, but that sounds good.
Yeah, I think there's also zoo or something. There are several options. Yeah, sorry, go on.
Yeah, so clock is in the same family as lubridate.
Ah, okay.
And I think it's distinguished by, there's some functions that maybe are a little easier to work with conceptually. I'm not sure it's, I've had to work with dates and it's a challenge.
I'm sure, yeah. Although I would imagine that if you have a date column in your data, then maybe it's just one column and then maybe you can just use one mutate. Because the strength of across is that you can change several columns at a time, but you might not have several date columns in the same data frame, maybe. Yeah. But that's something I'd have to try. I'm not sure if that works.
Great. There's another question. Can across also be used to recode variables when you want the same changes for each one?
Yeah, you can also do that. So if you wanted to add 1000 or something to every numeric variable, is that what's meant? Yeah. Yeah, that's possible. That's possible for sure. Yeah. I would have to look it up, but I've seen it in the documentation, in the vignette. I've seen an example. So when you work on the exercises, maybe I'll quickly check.
Like that, there's another question about if we can take all the columns that are numeric rather than giving names. And I think there you just do across is dot numeric, right?
Yeah, you do across where is numeric. Yeah. Yeah, I I know that I've seen a code snippet that can do that, so I'll try and dig that out.
Okay, those are the questions so far.
Yeah, great questions. Okay, where was I? Here, I think. Okay, so what you can also do, you can do everything that you can do in select. And in select, you can select variables by their position. So here we would like a summary, so the mean again, for variables from budget to international gross. So that would mean budget, domestic gross, and international gross. So here we're using this colon to mean from this variable to this variable. Let's just try that, and that works. And we can also just give it a vector. So we can just use this C syntax and then write all the variables that we want in this vector. So let's try that. And then we just get the mean for these two variables. Or you could, of course, write more in there if you wanted to. Okay, and this is really useful, but it gets even more useful if you use something like a group by. So we have this Bechdel test result. So the Bechdel test is this kind of minimal test of representation of women in a film. So a film passes that test if there are at least 2 women in the film. They both need to have names, and they need to talk to each other in the film about something other than a man. So if a film has those characteristics, if that happens in that film, it passes that. And the binary variable called binary here in this data set just codes that for pass or fail. So let's say we want to see the mean of all numeric variables, but we want to see that done separately for whether a film has passed or failed the test. So we need to add this group by before we do the summary. So I'll just show you what that looks like. So now you can see if a film fails the test, what was the average budget, what did it earn, right? So you see the summaries for all these numeric variables, but done separately for whether it fails the test or passes the test. Okay, and what you can also do is, so we've used the mean just as an example, but there are more measures that you can calculate in Summarize. So here we have a list of mean and standard deviation, just to show you that this is possible as well, right? So here we have, let's go to budget. Here we have the average budget, and we have the standard deviation, the average gross, and the standard deviation, and so on. So you can give this a list. Okay, and what we can also do is count. So for categorical variables, this is not super useful in this data set, but just so you've seen it at least once. So we can say count across all variables that contain test. So that would be just test and clean test. So the way this was done, I think, was that there were some films where different raters probably disagreed. And then this is kind of the final rating that they gave that film. So this is just a bit more specific. So this film would have women, but they wouldn't talk, for example. This film doesn't have women. This one passes, for example. And if you do count across these variables, it basically looks at the combination, the unique combination of the selected variables, and counts how often they appear in the data. Okay. Yeah, and like I was saying, here's a link to the vignette, so to kind of an extended tutorial, which has a lot more information because across is really powerful. And yeah, I also need to reread that vignette a couple of times to really get a better sense of what it can do, because it can really do a lot. Okay, yeah, questions before we move on?
Oh, nothing in the chat yet.
Okay. All right. Okay, so we've talked about across, and we've said this is column-wise, so column-wise operations. So now we'll talk about kind of the opposite case, so row-wise operations. And for that, we'll just make a tiny little data frame that we'll just call df. It's just an example. So here I'm creating it. And then I'm just printing it. So this is really simple. This has two variables, just called variable 1 and variable 2. And they contain 2 and 4 and 8 and 4. So what we would like to do is we would like the mean of the first row, right? So 2 plus 8 divided by 2 is 5. And we would like the mean of the second row, right? So 4 plus 4 divided by 2 is 4. Yeah, pretty simple. But we would like the mean of this row and the mean of this row, and we would like that to be in a new column. So we would like a new column that contains these averages. So let's try that. We can say, okay, new column, that's mutate. We would like to call it mean variables. And then we know we can use mean, and we can give it a vector of these two variable names, right? So calculate the mean of these variables. Let's run that. And we can see that it makes a new column, that it puts 4.5 into, both of these rows, okay? So what it does is it calculates the mean of these 4 numbers. So it calculates 2 plus 8 plus 4 plus 4 divided by 4 is 4.5. So what we would actually like to do is we would like to tell R, we'll do everything separately for each row, because right now it's doing everything for the entire data frame. But we would like to have it separately for each row. So we need to add row-wise and then pipe it into this mutate call. And I'll just prove that it works. So now we get the result that we expected, 5 and 4. So now it did it separately for each row. And this is a bit like group by. So group by, that was when we told R to do calculations separately for specific groups, like we just did with calculating the average budget, depending on whether a film passed or failed. So separately for pass or fail, that was a group by. So here, this is a bit similar, but here it's as if every row was its own group, right? So this just tells R, do everything that follows separately for each row. And then let's say we want to continue on. So if we had group by, we need to use ungroup to make R forget the grouping and continue as normal. And we also have to use ungroup here, right? Just to make sure that R then continues doing things as normal and doesn't do things row-wise again, right? So we just need it for this mutate. And then if we want to continue on, we should use ungroup. Okay. So because this is a tiny data frame, I wanted to show you a more realistic example. So we have a data frame that's called Brazil, and this actually contains deforestation, so causes of deforestation in Brazil for several years. So you can see we have a year column, and then we have columns for the different reasons, right? So commercial crops were planted, there was flooding, natural disturbances, fire, mining, and so on. Different reasons, and you can see how much forest was lost each year due to whatever reason. What we don't have, so these are all the different reasons, what we don't have is a total amount for each year, right? So we would like, so each row is a year, so we would like R to add up this and this and this for this first row to get us to the total amount of forest that was lost in 2001, and then do that for each row. So again, this is where we need row-wise. So here you can see I'm piping it into row-wise, and then I'm saying, okay, I mutate because I want a new column. The column should be called total deforestation. And then this should be the sum of all of these columns. Okay, so the new columns are always added at the end. So I need to go all the way over here. And you can see I have that column now. So obviously this is a lot to type. If I have to type all these variable names in one by one, that's not ideal. But we can use across, or we can use kind of a variant of across. It's called C across to again use this select syntax. So here we can say mutate total deforestation is the sum of variables from commercial crops to small scale clearing. And we have to use, because we're doing things row by row, so because we have row wise, we need to use C_across instead of across. That's just something to remember if you use row wise and you want to use this across idea or syntax, you have to write C_across. So that works. There's an even simpler way of doing it. So in select, you can also do minus a variable. So select everything but that variable. So here we want the sum of all the variables except year. So we can write sum C_across minus year. And that works just the same. So these two blocks do the same thing as this one as well. These are all just ways of writing it a little bit shorter, a little bit simpler here. And yeah, so you can also use summarize with that again, but it probably makes more sense for mutate. Okay. And again, I've linked to the vignette because there's a lot more that could be said about row wise. Yeah, questions before we move on to some exercises? All right. So in that case, we'll move on to the next topic. So next is a really useful topic or a really useful set of commands that often cause a little bit of a headache. It's a little bit, can be a little bit tough to get into that. So please don't be shy to ask me to repeat something. Yeah, so I can see someone's raising their hand. If this is a kind of a debugging your code question, because I think I've seen you post something in the chat, maybe we could have a look later just to save time, if that's okay. Is it just is it a debugging your code question?
Yeah, I think I can help in the chat.
Okay, that would be great too. Just so we can get through our topics. That would be nice. All right, so reshaping data. So what does that mean? What do we mean by reshaping data? So two options. You can make your data longer. So what that means is have more rows. And often that also means have fewer columns, right? So more rows would make it longer. And the command that we'll discuss here is pivot longer. And the opposite would be making your data wider. So that would mean decreasing the number of rows and often increasing the number of columns. Okay, so making it longer, adding rows, and making it wider would be adding columns. So why do we need that? Pivot longer, so making your data longer, adding rows, that's often something you need to do when you download data from somewhere. So that's what I mean by wildcard data. So if you download some data from, maybe you've done a questionnaire and you're downloading the answers, downloading the results. Or it happens a lot that when you download data, it won't really be tidy. And when you try to visualize that data, you'll run into problems and you realize, okay, something's wrong here. This is not really tidy data. And often the solution is to use pivot longer. Pivot wider is not as common for tidying data, for cleaning data, but it's really useful for making summary tables look prettier. And we'll see examples. So if that seems very abstract, that's because it is right now, but we'll see examples. So we'll stick with this plastics data set. And I'll just show the head, first couple of rows again. Okay. Right, so you can see here that we have these different types of plastic, right? How much of each of these types of plastic was collected in each of these years. So let's say we would like to create a bar graph On the x-axis, we would like to have these types of plastic. And then we would just select it. That's the basic plot that we would like. But we can't really do that right now because we would need to say, we would need to use ggplot and tell ggplot the variable for the x-axis is what. There are several variables that should go on the x-axis. So those all need to go, somehow we need to have one variable that just contains this. So these abbreviations for the different types of plastic. So one variable called maybe type of plastic or something like that, that contains these abbreviations. So, and then we would need another column next to that that contains the numbers, right? So we don't want to lose any information, right? So when we pivot, we don't want to, obviously don't want to lose any information in our data. We just want to kind of reformat and reshape it, right? So we would like one variable that has these abbreviations, and one variable next to it that contains the amounts, the numbers. So in other words, if you try and imagine this, and I know it's hard to imagine, we want to make it longer. We want to have more rows here, right? Because instead of having, so we would basically need this first row here, we would need that to be 1, 2, 3, 4, 5, 6, 7 different rows, right? We want to make it longer. And you'll see in a second what that looks like. Okay, so we need pivot longer here to make it longer. And the arguments, or the basic arguments here, are which columns should we reshape? So which columns should be concerned by this? Which columns should be rearranged somehow? So here are the columns that we want to rearrange. I'm just listing them, so these are just the different plastic types. Okay, and then the next argument is names to. So that refers to what should happen to the variable names. So what should happen to O, PET, PP, and so on? What should be done with that? They should be put in a new column. So what should the name of that column be? So that's what names to is asking you. What should the name of the new column be? And I want to call that plastic type. So plastic type will then contain these. And the values, what should happen to the values? So the values are all these numbers that we have here. They also need to go into a new column. What should that column be called? I'm just calling it plastic count, right? So these are names that you set here. Okay, and you can see, so I'll run that in a second, but you can see that here I'm saving that to a new data frame. So I like to do that whenever there's a big change to the data frame, so pivoting or also joining, which we'll do later. I like to give that a new name instead of overwriting the old data frame, because this is completely reformatted. So this is a big change, and it's a bit annoying to have to undo. So I'm just saving that as plastics long. Okay. So the first thing that we can see, if we look here in the environment, we have, so the original data set had 13,000 observations, so rows, observations just rows. And the plastics long data frame now has 93,000, so it's definitely longer. So if you look at that now, you can see, okay, you still have the country, the year, this parent company, this is just no brand, no company. And then we have plastic type as a new column, and that contains these different plastic types. And then plastic count, so how often each of these were found. So the information that is here, that used to be in one row, right? So I'll just scroll up. So you can see, so this used to be just in this row. So we've taken that and we've reshaped it to make it longer. And now you can imagine we could make a plot that has X is plastic type and Y is plastic count. Okay, so for this, oh, sorry, yeah.
Yeah, could you, there was a question in the chat, which is a really good question, which is how this relates to gather and spread.
Yeah, gather and spread are the old, I think these are kind of the older ways of doing the same thing. So this was changed to pivot longer and pivot wider. Some of and pivot longer and pivot wider can also do a couple of other things that spread and gather, I think, didn't used to be able to do. So it's kind of extended functionality. And it's also, I think the argument is also that it's easier to remember what these two pivots do. So pivot longer is pivot to longer, pivot wider is pivot to wider, so make it wider. Whereas spread and gather, I'm struggling to remember what each of these did. I think gather is longer and spread is wider. So I think, yeah, I think they changed it to add some functions and also to make it a bit more intuitive, but it's the same principle. Yeah, it's the same principle, same idea. There are also, I think there are also packages. I don't know the name of the package, but there's also melt and cast or something like that. So there are different ways of doing the same thing. But yeah, pivot, I find pivot definitely the most intuitive, and there's a link to the documentation later, and if you have a look at that, it's very long because it can do a lot of different things. Yeah, so it's very powerful, but it's also a little bit tricky to remember what's going on here. Yeah, anything else? Okay, right, so, oh, whoops. Okay, so so we can list all these columns that we want pivoted here, right? And you can see that everything that's not in there is just kind of copy and pasted, essentially, right? So everything that's not listed in the columns is just copy pasted, okay? We could also use this -c syntax to say pivot everything but these three columns. So this and this does exactly the same thing, right? So if you have a lot of columns that need to be pivoted, sometimes it's easier to say, just ignore those, don't pivot those columns, but pivot everything else. Okay, so this is just an alternative way of writing that depending on how many columns you have of each, might be easier on your fingers, so less typing to do. Okay. All right, so let's look at pivot wider. And as I was saying, pivot longer, you often need to use that to tidy data so you can visualize it and do modeling or whatever you want to do with it. But pivot wider is, I haven't really ever seen that used, at least not in my own, in the data I've worked with, to clean data, but you can use it to make nicer looking summary tables. So to show that, we'll first do a little summary. So this first part is nothing new, really. So we're dropping missing values in the plastic count, so they just don't bother us anymore. And then we would like to count how often each kind of plastic was found per year. So we need to group by year and plastic type. And you can see we're doing that with our new plastics long data frame. So it would have been tricky, I think, to do that with the old plastics data frame. And that's one of the advantages of having data tidy, right? You can use the same tools again and again if the data is formatted the same way. So we're grouping by year and plastic type, and we would like plastic sum to be, yeah, the plastic count for each of these years for each of these types. So that's what it looks like. You can see we have 2019 HDPE 9,320, and so on. So for each year, and it's only 2 years in here, for each plastic type, we get the amount. So I'll just show you the rest of it. Okay, here's 2020. Okay, so this is a summary table that works fine, but it's not the nicest table to read. And a reason for that is that you have these years repeated, and you would kind of like to flip that in a way. So you would like to get to a table where you have 2 columns with the 2 years, and these plastic types, that these are kind of row labels. So for that, you can use pivot wider. Okay, so this first part is the same. I'm just doing the summary, and then I'm piping into pivot wider. pivot wider needs to know where should the column names come from and where should the values come from. To show you what it looks like, because it makes it a bit easier to explain. So this is the pivoted table now. Right, so now we have plastic type as one column with these different plastic types, and then we have 2019 and 2020 with the amounts that were found. Okay, and before that we had a column that had year, a column that had plastic type, and a column that had plastic sum. So we're telling pivot wider, take the new column names from year, right? So 2019 and 2020 are the new column names, and take the values in that from plastic sum, so from the amount of plastic that was in it. Okay, so this is more of a reformatting issue rather than a data cleaning issue, but it's useful. And here's again the link to the vignette, so to a really detailed tutorial with lots of different example data frames. So what I would recommend, because pivoting is not the easiest thing, if you have a data frame and you think, oh, I think I need to use probably pivot longer, but it doesn't quite look like these pretty simple examples, then have a look at the vignette, because there are lots of really special cases where you can do, really sophisticated, data cleaning.
Great, so we just will have one more topic to cover today, and that is joining data sets. So for this, we're going to return to the Bechtel test, the movie data that we had above. So we have, in essence, we have two data sets here. One is called raw Bechtel, which has the year and the ID and a whole bunch of information on like test results, but it's actually kind of small. So it only has 5 columns. That's like a title, a rating, and so on. But then we also have this movies one, and that has a bunch more information. So we looked at this earlier in the talk where we saw like all this information about budget and domestic gross and so on. So say we want to put these two together. So depending on what kind of information we want, we can use a couple different types of join. And Tidyverse or R has a couple different fundamental types of join that you can use depending on what you want to do when there are rows in one data set that don't show up in another data set. This might seem like it would be uncommon, but it's usually very common. So this is usually a pretty important decision on what kind of a join you want to use, so that you don't end up losing data that you don't realize you're losing. So the syntax for this is always like a certain type of join underscore join, and then you just give the data frame names and what you're joining by. We'll see that a bit later, but first of all, the 4 types of join that Tidyverse has is the left join, the right join, the inner join, and the full join. So the left join, if you think about this first data set as being on the left on the screen, or whichever one that you give first, that's going to be the left one. And when you do a left join, what you're saying is you definitely want all the rows from the left data set. And if there's one that's not in the right data set, that's okay. You don't need it. Whereas the opposite is true with the right join. You want to keep all the rows from B, so the one that's kind of on the right here, also in the syntax. And if there's not a corresponding one in A, then that's okay. Then you can just give an NA. Then an inner join, you are only retaining rows that show up in both of these two. So anything that shows up in one but not the other is dropped. Be really careful when you're using those in case you have something that's spelled wrong. You think it's in both, but it's not. And a full join keeps all rows in both data sets. So you can see here, like the C is not in B and D is not in A, but it keeps both of them in this little example. It just throws an NA in the open space. So I'll show you a full join first. So if we full join the movies and the raw Bechtel data, you'll see that, these ones are all represented, but then if they are not represented in one of the data frames, then they will get an NA for that section. So we can look. I hope you can still hear me. So I'm getting message that my internet is not good.
Yeah, you just cut out for a little bit. There's an example further down where we show a film. I think that's only in one and not the other.
Yeah. Okay.
Yeah, the phantom for some reason.
Yeah. Okay. So we'll see that more specifically, but yeah. So here we've also showed, like, here I just did it as a preview, and you can look through it. And here I have named it to a new data set. It's always good to give it a new name, because sometimes you lose rows when you join more often than you think. So it's always good to have it as a new name. Yeah, and this is what Julia was saying. For example, when we look at the phantom, which existed in the raw Bechtel data but didn't exist in the other data set, you can see that, like, since we did a full join, it still exists. It still is present in our join data set. It hasn't been dropped, but it has just a bunch of NAs where we don't have that information because it wasn't in the other data set, the movies data set. So it keeps only what was there, and it adds a whole bunch of NAs. But at least you have, like, some indication that this row once existed. Then, so a left join, here we have movies as our left data set because it's the one that we gave in first. So when we do a left join here, then anything that was any row that was in the movie data set is still in this data set, even if it wasn't in the raw Bechtel data. And the opposite happens when you do a right join. So if you keep the order the same, then a right join means that anything that's in the raw Bechtel data is kept, but if the movies, a row in the movies is not in raw Bechtel, then it's not kept. So you can see that this is going to have less rows, or this one has less rows, depending on which data set is bigger. Okay, and then finally there's the inner join, and the inner join just keeps every row that's in both. So here will be kind of our smallest data set because it only keeps rows that exist in both data sets. And everything else is permanently gone from this data set, from what you've named it over. So that's the only point of caution. So here we can try that out exactly with this phantom. So you remember that the phantom didn't exist in the movies data, it only existed in the raw Bechtel data. So when we did the inner join, now there is no row called the phantom. So you can remember that when we did the full join, it still shows up. It just has a whole bunch of NAs for the data that we don't have. But when we did the inner join, it's just gone, doesn't exist. Okay, and so far we haven't used this by argument, and you can see R is actually automatically deciding what to join it by. It can automatically find if data sets have the same names. So the movies data set and the raw Bechtel data set have a couple of overlapping names. I think it's like IMDb and the title, and maybe also the year. So it can do that automatically if the names of the columns are exactly the same. But if they're not exactly the same, you have to give them. So for example, you could do by, and then you could give a vector with the data, with the columns to join by. And you can also specify if they have different names using like an equals sign here. Yeah, so that's the basics of joining. We actually don't have an exercise on this because we would have to give you a lot more data sets than we already do. There's a couple more options that I didn't mention. One of them is a semi-join, which doesn't duplicate rows in the first data set. You don't need that too often. An anti-join will take whatever's in data set B and it will kind of kick it out of data set 1. So you can use that. We use that in text analysis to kick out words that we don't want in our analysis. Or you can use it if you have some sort of like a blacklist or like a block list and you want to kick any of those rows out of a previous data set. You can use an anti-join. And two similar things which are not exactly joining data sets. So here we have like two different data sets with the same name. Some columns have the same names, but others have different names. But if you just want to add columns to a data frame, then you can use bind columns. So there's no overlapping columns, but the rows are like in the same order and you just want to put them next to each other, then you would use bind columns. And bind rows would just be if you had a whole bunch of rows where the columns were the same and you just want to put it on the bottom. Yeah. Yes, and of course, be careful with the structure of your data because.
Oh no.
Oh,
Kyla, you're breaking really badly right now. I don't know if you
Yeah.
It was like a few seconds, but enough that we lost information, I think.
Oh, I'm sorry.
Yeah, maybe
Okay,
you could
so-
just repeat bind rows and bind columns just to make that
Mhm.
clear. I think that would be good. Yeah.
Sure, yeah. So bind rows is when you have an additional data set which has new rows, but the column structure is the same as your existing columns. So in essence, you could just exactly the structure that it's in, you could just kind of put it on the bottom of the data set and continue with rows. That will only work if the column structure is consistent. And bind columns is if you have kind of the opposite. So you have columns that you want to just add on to the side of the columns, but the order is correct. So the order of the rows matches with your existing data set. So you always have to make sure that the structure is the same there. Yeah, and there's more information on joining, again, on like a pretty good vignette that you can check out. But that's the basics. Yeah, are there any questions?
No, I don't see any questions right now. If you have any, get them in now.
Yeah, we'll wrap up with any final questions on today's whole
whole deal. So binding is like appending new data. Yeah, it's like appending new data. You could say that. It's just a bit, so bind rows and bind columns, you have to be just extremely careful with both of these options, because when you join R, when you use any of these joins, R will basically check that there's overlap and that it makes sense to kind of glue these data frames together. But if you bind rows or bind columns, it's just matched by position. It's just added on. And if the order or the structure isn't exactly the same, that can go really wrong. So there are some scenarios when you might want to use that, or when it makes sense to use that. Let's say you have a questionnaire running online, you download data, and then a week later you realize, oh, 5 more people have participated, and you download data and then add that on, and you're sure the structure is the same, then that's fine. But generally, I'd be pretty careful with bind rows and bind columns. I get the usage of bind rows. Can there be any real life examples for bind calls? Yeah, if you wanted to, yeah, go on.
Sorry, I was just going to say it's essentially like matching by position. So if you have a data set that has no overlapping columns with your other data set, so if you to join something, at least one column has to be the same. So either you have to have like an ID or like a participant name or some column of reference that R can use to match them. If you didn't have it on your other data set, but you know it's in the correct order, for whatever reason, this is more likely to be the case if you have a small data set than if you have a big one. But if you knew that it was the correct order, but you didn't have like an ID column, you could just put it on the side. That can also happen if you have something that was like manually entered. But it's just good to know that that is like an option that exists.
Yeah, exactly. More variables for the same observation. Yeah, that's right. Okay, yeah, anything else? Okay, I don't see anything. Yeah, so in that case, yeah, thank you very much for sticking with us. It's been really lovely to see a lot of the same names from, session 1 of this series to now session 5, the final one. So that's been great. Thanks for sticking with us. And we really hope you'll continue, coming to our workshops. We really hope you like them. So hopefully we'll see you in the Guided Tidy Tuesday or in, any other of the workshops we have planned. So make sure to check us out on Meetup, and also make sure to follow us on Twitter, also for these data set polls that we'll put up very soon. And